Everybody can hear me, right? Everybody can hear me?
Yes,
Yes,
sir.
Yes.
sir.
Yes,
Yes, sir.
All right, good. So we are carrying on with the matrices. As I said, we are finishing with this topic this week because we want to get to the nice transformation next week. All right, so today we're going to finish off with the notes part of it, and then we're going to do some questions, practice some questions. On Wednesday, we're going to start the class on Wednesday by practicing some more questions, and then I'm going to give you a nice classwork to do. And the classwork is going to be easier than the questions that we practice. Right? And all the questions we're doing today are from past papers, as you know. So I'm actually going to show you the actual past papers, and you'll see that we are doing real past paper questions. And as usual, if you can understand and do it in the class, then you'll be able to do it in the exam as well. All right, so let's just finish the notes part of it. We have a couple important things to do, and then we'll get to the questions. All right. All right, so the first thing we're going to look at is transposition of matrices. All right, we'll just continue from where we left off yesterday. And the first thing is transposition of matrices. Now, historically, I can only recall CXC set a question on this just one time, and it was on a multiple choice paper. And the reason for this is that transformation of matrices really is a tool that is used in matrices at the higher level. So when you do pure maths unit 2, and you have to do matrices at pure maths unit 2, that is when you're going to use this tool in matrices to transpose matrices. So at the CSEC level, you don't really have any purpose, no real purpose of transposing matrices. But still, what is transposition of matrices? But it's on the syllabus, and as I said, it appeared once that I can remember on an exam paper, and so it possibly can occur again, can appear again. What is transposition? It's basically interchanging a row, interchanging the rows of a matrix with the columns of a matrix, and it's usually done with square matrices, right? But this is it. So it's basically when you transpose, a matrix is transposed by interchanging rows with the columns of a matrix. So a simple example is that if you have this matrix 3, 4, 5, 6, if I interchange the rows, or as I can say, I make the rows become the columns and the columns become the rows, then we would have formed the transpose matrix of A. And the T on the A here means that we have transposed it. So you notice then that this row 3, 4 is now this column 3, 4, and this row 5, 6 is now this column 5, 6. As simple as that. That's how we transpose. If I do a little quick example over here, if I have a matrix B, and the matrix is 8, -3, 1, 7, then the transpose matrix of B, I just write the 8, -3 down here instead, and put the 1, 7 down here instead. And that is it. What happens is that that was the first row is now the first column, and that was the second row is now the second column. And that is as simple as that. All right, I'm not going to spend any more time on this because it's very simple and straightforward. And I said I only see CXC ask a question on this one time on a multiple choice paper. Never seen them do it, asking a question about transposing matrix again. All right, so that is that. All right, so that's that. So that is the transpose matrix of A. Then we'll come to the adjoint matrix. So now we're going to be looking at some of the tools, I'm going to call these the tools that we use to carry out certain functions, certain activities with matrices. And you're going to see a lot of those activities when we do transformation. We're going to use a lot of matrices in transformation. Right? And there are some little tools that I just want to call them tools. Like for example, the adjoint. This is what we call the adjoint of a matrix. And the adjoint of a matrix is used in diagonalizing a matrix. Remember we said a diagonal matrix. Is one where only the elements on the diagonal, the leading diagonals, for example, 1, 3, and you have 0 here and 0 here. That's a diagonal matrix because only the elements on the leading diagonal are not equal to 0. So the adjoint is used to diagonalize a matrix. It's a tool that is used in diagonalizing a matrix and also helps in calculating the inverse of a matrix. And it's called the adjoint. And it's a simple way to calculate adjoint matrix when it's a 2 by 2, which is what you will get in CSEC. All right. So if our matrix that is A, B, C, D, then the adjoint is formed. The adjoint is formed that way. So let's look at the details of how the adjoint is formed. And it's very simple. All right. The elements on the leading diagonal are interchanged. See them here? The elements on the leading diagonal are interchanged. That's the first step. So the AD, what was AD this way, is now AD that way. So you interchange the elements on the first diagonal or the leading diagonal. That's the first step. Then after you do that, then you leave these two other elements on the second diagonal. Leave them where they are. Leave them where they are. And you just change the sign. That's how you form the adjoint matrix. And the adjoint matrix is written with a D on it right here. And the D is because it is used in diagonalizing the matrix A. You want to form a diagonal matrix, you use the A and the AD. And that's why the D is there, because you form a diagonal matrix. So the D on the adjoint matrix is really for diagonalizing. So look at the details of it again. First step is to interchange the two elements on the leading diagonal or the first diagonal or the main diagonal or the primary diagonal. Remember, every word that means first is used to refer to that diagonal. And those two elements are interchanged. And then the other two elements, which are on the following diagonal or the second diagonal or the trailing diagonal, any word that is used to mean second, those two elements, you leave them where they are. Don't interchange them. Leave them where they are, and you just change the sign. Change the sign. And that's how we form the diagonal matrix. And what it is that what is the diagonal? What is the significance of the diagonal matrix? Is that when you multiply a matrix and the diagonal matrix, you form and the adjoint matrix. So when you multiply a matrix and its adjoint, you form a diagonal matrix. And that's what this is basically saying. A matrix multiplied by its adjoint matrix is equal to a diagonal matrix. See there, a matrix multiplied by the adjoint matrix is equal to a diagonal matrix. Or an adjoint matrix multiplied by the matrix still equals a diagonal matrix. All right, so let's do an example. All right, so let's use an example. So these two matrices are adjoint of each other. If you look at it, these two matrices, hold on. These two matrices right now are adjoint of each other. Notice the 2, 4 right here is interchanged to 4, 2. You can see that. And you will also notice that these two elements, they stay where they are, but they change sign. The change sign. All right. And when you multiply these two matrices, you're going to end up with this. I'm not going to go through the process of multiplying now because we focused a lot on that yesterday. Right? But if you're multiplying them as usual, you would use the rows of the first matrix times the column of the second matrix. When you multiply them, this is what you're going to get. I'm not going to go through the steps right now. That's a diagonal matrix. This 5 is particularly important, and it is actually called the determinant, which we're going to look at in the next slide. All right, but that's what you get when you multiply a matrix and its adjoint. This is the adjoint of this matrix. When we multiply them, we end up with that matrix, which is a diagonal matrix. It is a diagonal matrix because only the elements on the leading diagonal are not equal to 0. All right, so that is that. So that's the first tool that we're going to be using, that we're looking at, the adjoint matrix. All right, so the next thing we're going to look at now is the determinant of a matrix. I might want to say the determinant is used to determine if a matrix has an inverse or not. That's just something that I've come up with. The determinant is what decides if a matrix has an inverse or not. because I can tell you from now, if the determinant of a matrix is equal to 0, then that matrix will have no inverse matrix. It will have no inverse matrix. All right. And for the purpose of the transformation, the inverse matrix really reverses anything that the original matrix would have done. So anything that you use an original matrix to do, the inverse matrix will reverse that result, will reverse it. We're going to see that when we get to transformation. But for now, how do you calculate the determinant? How do you calculate the determinant? If your matrix is A, B, C, D, then the determinant is equal to the product of the elements on the leading diagonal, the product of the elements on the leading diagonal, see it here, that is AD, minus the product of the elements on the following diagonal, minus the product of the elements on the following diagonal. And that's how we do it. So it's the leading diagonal product minus the following diagonal product. I might say the first diagonal product minus the second diagonal product. This is the first diagonal right here, and this is the second diagonal. All right. So the product of the elements on the first diagonal minus the product of the elements on the second diagonal. That is how you get the determinant. And as we said, the determinant is used to determine if you have an inverse or not, if the matrix has an inverse or not. And we're going to look at that just now. All right. So that is the determinant of A. So if we're doing it with some values now, just to demonstrate, I want to find the determinant of that matrix, B. B is a matrix 3, 4, 5, 6. And we want to calculate the determinant of B. Then all we do the first diagonal product, which is the 3 times 6, minus the second diagonal product, which is a 4 times 5. All right, and you can see that. All right, the 3 times 6, which is this, minus the 4 times 5, which is that. And that is 18 minus 20, which then is equal to negative 2. So the determinant of B is negative 2. All right, as simple as that. The determinant of B is negative 2. I'm going to look and see how we use the determinant afterwards. So somebody asked what was the determinant yesterday. That is it now. That is what we call the determinant. And it is used to determine if a matrix has an inverse or not. And we're going to look at that later. All right. It's also used to find the inverse matrix. All right, so you see the adjoint that we just calculated a while ago and the determinant, both of them are used to calculate the inverse of a matrix. The inverse of a matrix. And it's a simple formula using the determinant and the adjoint. And this is it. Now, if A is your matrix, A, B, C, D is your matrix, then the inverse of A is written A to the minus 1. So this is a symbol that is used for the inverse of A. Just as though when we have the function, I want the inverse of the function f, and write f to the minus 1. The same thing carries through here. Right? So the inverse of the matrix A is written A to the minus 1. And it is simply equal to 1 divided by the determinant multiplied by the adjoint matrix of A. That is how you get the inverse of A. A simple formula that you all must know. All right, we're going to be using it so many times, you will know it. Without even trying to memorize it, you will know it. So the determinant of the inverse of A is 1 divided by the determinant of A multiplied by the adjoint matrix of A. All right, let's put it all together now in an example. All right, so this is what it becomes. All right, okay, this under here now will be the determinant. This under here will be the determinant. Remember, this product minus this product. All right, that's the determinant. And then now the adjoint right here is obtained by interchanging these two to get this. And then leave these two where they are and just change the sign to get that. That's how we get the adjoint matrix. All right, simple as that. And then this calculation now, when you calculate it, you'll get the inverse matrix. All right, so you get these values, you usually have a fraction under here, and you divide each of these values by that value under there. We're going to see it with an example. All right, so that's it. Now, what's the relationship between the matrix and its inverse? And this is something that you must know. CXC asks this all the time. Relationship between a matrix and its inverse. And this is it. When you multiply a matrix and its inverse, you end up with the identity matrix. And that is it. A matrix multiplied by its inverse, or an inverse matrix multiplied by the matrix, equals the identity matrix I, the I matrix, 1, 0, 0, 1. It's almost like you're saying a number times its inverse equals 1, like this. 2 times the inverse of 2 is equal to 1. It's almost like you're saying the same thing. Right? So this is like a, and this is like a to the minus 1. And you multiply them, you get the I matrix. You get 1. Remember, the 1 now is your I matrix. So it's sort of similar. You kind of see some similarity in that relationship. All right. So it's not hard. It's not far-fetched to understand. Remember, we said that the identity matrix. Remember, we said that the identity matrix behaves just like the number 1, right? That's what we said. That matrix behaves just like the number 1. So note that these two are inverse of each other. And these two are inverse of each other. Because if you have the inverse matrix and you calculate the inverse of the inverse matrix, you're going to actually get back that matrix. All right. So basically, that is the relationship. A matrix times its inverse, or the inverse times the matrix, will always be equal to the identity matrix. And CXC will ask you that specific question. They'll ask you, for example, what is m times m to the minus 1? What is it equal to? And you have to know that it is equal to the I matrix, which is 1, 0, 0, 1. CXC asks if you know that all the time. Multiple times they ask at an exam. So this is one of the things that you must know. All right, and we're going to see it. We're going to see it in the examples later. All right, so let's continue again. So that's relationship. And they'll ask you to show it. I'm going to see a question maybe later. We'll actually ask you to show that a matrix times its inverse equals I, which is the identity matrix. All right, we're going to see it later. All right, so let's look at an example with values now. So we're trying to find the inverse of that matrix B. So B is that matrix, 1, -2, 3, -4. And I'm trying to find the inverse of the matrix B. In other words, I'm trying to find B to the minus 1. Remember, the formula is 1 over the determinant multiplied by the adjoint. That's the formula right here. 1 over the determinant multiplied by the adjoint. 1 over the determinant multiplied by the adjoint. That is what the inverse matrix is equal to. All right, that's what we get. All right, so we're going to use the values now. So first, I'm going to calculate the determinant. How do we get the determinant again? The leading diagonal product, which is the product of these two. That's what is here. Minus, the minus there. The product of these two, which is the 3, minus the product of these two, which is the 3 times the -2. That's the product of these two, 3 times -2. All right, and then when we're doing these things, we have to care for the minus that we have here, because this minus makes this a +6. So really and truly, this works out to be -4 plus 6. -4 plus 6 is now equal to that 2 that I have there, and that is how I get the 2. All right, so that's how the calculation will go. So the determinant of determinant 2, this value is coming right here for the 2. The 2 is going right there. So next thing we need to do now is the adjoint matrix. All right, so let's look at how to do the adjoint now. So the adjoint now is that. How did we get the adjoint again? Let's look at it again. We interchange these two. Interchange them to get this. That's the first step. Interchange those two. And after we interchange those two, then we leave these two where they are and just change the sign to get these two. Change the sign. Don't put them back as is, you know. Leave them where they are, but you change the sign. So what happens is that the -2 becomes +2, and the 3 becomes -3. Leave them where they are and change the sign. It's very simple. That's how we get the adjoint matrix. So this adjoint matrix now is going there. All right, and then we'll put them, two of them together now, the determinant and the adjoint matrix. Put both of them. Put this one here and put this one there. We end up with the inverse matrix. We end up with the inverse matrix. That's it. 1 over 2 times the adjoint. And what this means now is that you can actually now divide each of these values by the 2, or you multiply each of the values by half. Any way you want to look at it. To multiply by a half is the same as to divide by 2. All right? To multiply by a half is the same as to divide by 2. So you can either divide each value by 2 or multiply each value by a half. In any case, what you will end up getting is that your matrix becomes that. That's what we get. And so this matrix over here is the inverse of B. Right? This matrix is your B to the minus 1. And what do we know? If I multiply this matrix and this matrix, if I multiply them, I'm going to get the identity matrix. Let me show it over here. If I multiply them, if I do B times B to the minus 1, if I work it out, I am actually going to get the I matrix, which is 1, 0, 0, 1. Right? When I do a question, I will have to show it anyway, so you'll see it. I multiply these two matrices, this one up here, this one down here, the B and the B to the minus 1. I'm going to get the I matrix. All right, I'm going to end up with the I matrix for sure. All right, so that is the inverse matrix. All right, I'm going to just finish through the notes. Not going to spend too much time on these things, and I want to just see how we use them, and we're gonna get to the questions. All right, you need to watch by the video, solidify these things, work a lot of questions. All right, because the last what I'm doing today is what they most set in exam. You know? All right, what I'm doing today is what they most set, or what they give the most marks for in exam when they give matrices questions. All right, the inverse business. All right, so we're gonna look at how we use inverse now to solve equations. All right, so that's what we're going to look at next. Using the inverse matrix now to solve the equation. Remember, when we did functions, we said we could use the inverse function to solve the equations. Now we're going to look at how we use the inverse matrix to solve the equations. So you see, there are a lot of similarities. Everything in maths, you know, all the different areas in maths have a lot of similarity. So just as how we were able to use inverse functions to solve the equation, in a similar way, we can use inverse matrix to solve the equation, and I can actually show you the similarity. All right, if you remember for the functions, we said if f of x was equal to some number, then x was equal to f to the minus 1 of that number. That's what we said, right? We did function. We're going to see that the matrices have a similar sort of thing. Very similar sort of thing. Right? Because the inverse of a matrix is kind of similar to the inverse of a function. Because a matrix also can do similar things that a function can do. All right, and we're going to see that with the transformation. But anyway, let's get into it. So let's say we have a matrices equation, ABC. AB equals C. So what I'm saying is that this is a matrices equation. This is the proof of it, right? Or the build-up of it, of the theory. So that's a matrix A multiplied by another matrix B equals another matrix C. And for the purpose of this demonstration, it is a B that we don't know, right? The B matrix we're trying to find. So let's say that this is our unknown B, just as how the X was the unknown here. Here the X was the unknown, right? Let's say that it is a B that we don't know. So how do you get the B? Right? How do you make B the subject? All right. So the theory is that what you have to do is that you have to get rid of the A. You have to get rid of the A. Right? You have to get rid of the A. So to get rid of the A, what you have to do in matrices is you have to multiply it by the A to the minus 1. But if I multiply the left side of the matrix by A to the minus 1, I also have to multiply the right side by A to the minus 1. All right? And basically that's it. So that's a concept. If AB equals C, and I multiply the left side by A to the minus 1, then I also have to multiply the right side by A to the minus 1. The important thing, however, is to remember that matrices multiplication is non-commutative. Matrices multiplication is non-commutative. And so if I multiply A to the minus 1 by AB, then I have to multiply A to the minus 1 by C. I have to put A to the minus 1 in front of both of them, right? Because matrices multiplication is non-commutative. All right, so that's what I'm doing there. Multiply both sides by A to the minus 1, but the A to the minus 1 must go in front of each one. Right? So it's simple enough. If AB equals C, if I multiply AB by A to the minus 1 in front, then it will be equal to the same result as multiplying the c by a to the minus 1 in front. That is a concept. I'm going to show you another example later where you have to multiply the a to the minus 1 behind. All right, this is in front. I'm going to show you when you have to multiply it behind. But let's focus on this one first, because this is the one that they mostly set in exam, the one we have to multiply in front. All right, so that's why we're focusing on this one. So that's what we get. So multiply both sides by the a to the minus 1. This side by a to the minus 1 and this side by a to the minus 1. Then now, remember, because the matrix multiplication is non-commutative, you have to multiply it in the direct order that it appears. And so you have to multiply the a to the minus 1 times the a first, because matrices multiplication is non-commutative. And what did we say about a times a product of a matrix and its inverse? That's it. You have to do those first. So multiply the a to the minus 1 times the a. And we know that a to the minus 1 times the a is equal to the identity matrix, which is just like the number 1. A to the minus 1 times a, as we said, will be equal to the I matrix, which is just like the number 1. So that is what we are saying. The a times a to the minus 1 is actually equal to the I matrix, which is 1, 0, 0, 1. Just think of the I matrix as 1, as a number 1. All right. And what will happen now is that the a to the minus 1 a becomes I. The a to the minus 1 becomes I. Everybody can see that. A to the minus 1 times a, this becomes that. All right. And then the b comes back here, and the a to the minus 1 and the c comes back there. All right. But the a times a to the minus 1 becomes the I matrix. And the I matrix is just like a 1. So it's almost like I'm saying 1 times b. Just like I'm saying 1 times b. Because the identity matrix, as we said, is the identity for multiplication. It behaves just like the number 1. So it's almost like I'm saying 1 times b. So 1 times b is b. So what then happens is that this side just becomes b. It just becomes b. All right. And that's what we get next. That becomes b. And so you end up with b, which is what we're trying to find. We're trying to find b, remember. Started out thinking that we're trying to find b. b is now equal to a to the minus 1 times the c. And as I said, you can make the connection with functions. Remember with that function, as if this was f of x equals a number. So the f is like the a, the x is like the b, the x is like the b, and the n is like the c. And then what happens down here is like we get x equals f to the minus 1 times the n of the n. So you see the kind of similarity in how the expression appears. All right. Well, it's not that really, but it's sort of similar. There's some similarity in it. All right. But at the end of the day, what happens is that a lot of the times you don't need to show this step in here. There are some questions where you need to show it. Some questions you don't need to show it. Some questions will take you through the steps. It's like they force you to go through these steps. But generally speaking, you don't have to go through the steps. Just as we know, say in the functions, this implies this. We can also know that this thing implies that. And we don't have to show these steps in there. You don't have to. Sometimes you have to show it, and the question will let you know when you have to show it. Other times you don't have to show it, and then that is the result. It's almost like you just transpose the a in front here and multiply by a to the minus 1. But you have to, in the back of your mind, and you have to understand that really and truly, this inside here that we have marked is what happened, what took place, why we can jump from this to this. You have to understand that this is what took place. You multiply both sides by a to the minus 1. It is very important that you understand that that is what took place. All right, and that is it. And so we can conclude in the box that if AB equals C, then B equals a to the minus 1 times C. All right, if AB equals C, then the B equals a to the minus 1 times C. And that is what we can use. And that is how we'll be using the inverse matrix. See here? We are now using the inverse matrix. Here we are using the inverse matrix to solve an equation where we're trying to find the B. So this is an equation where we're trying to find the B, and we're using the inverse of A to find the B. That's how it is done. All right? That's how it is done. So the most you can do now is actually do it with an example. So it's an example. So in this question, I'm saying find the value of A, B, C, and D if we have this matrices equation. So this is like our A, this is like our B, this is like our C, and we're trying to find the B. So based on what we just did, the B would be equal to the A to the minus 1 times the C. So we need to work out the A to the minus 1 of that, the inverse of that, and use it here. That's what the boil on to, you know. Simple as that, you know. All right. So let's show it. So we're calling this M. We're calling this actually M. We're calling this matrix M. We're calling the first matrix M. The matrix here. Instead of calling it A, I'm calling it M. This matrix. Like I'm calling it M. All right. And then if that matrix is M, then the A is going to be equal to this matrix that we want is going to be equal to M to the minus 1 times that, based on the transposition that we just did. How that happens? Because the inverse of the M comes in front, that to leave the B as a subject. Comes in front. So we need to calculate the inverse of M, M to the minus 1. We need to calculate M to the minus 1 there. That's what happens. All right? And the M to the minus 1 is equal to 1 over the determinant. Now note, another way of writing the determinant is this way, with the modulus symbol. This is called a modulus symbol, these two lines. That's another way of writing the determinant with those two lines. So the determinant of M, could write it like that, or you can write it like that. So some questions you'll see it like that, questions you'll see it like that. It means the same thing, the determinant. All right, that's the determinant. Mute your mic, please. Somebody just came on. Mute your mic, mute your mic. Mute your mic. All right. So continuing here. Let's erase that. All right. So that would be the inverse matrix. Now, how did we get the 1 under here for the determinant? How did we get the 1 for the determinant here? It will be this product minus this product. Let me work it out and show you. So it will be 1 times minus 3 minus 2 times minus 1. That's how we'll get that inverse, that determinant, sorry, that goes there. And if you work this out, you see that it becomes -3, -3 plus 2. -3 plus 2 is -1. That's why this value is -1. All right, that's why that value is -1. Then the adjoint matrix now, which is this adjoint matrix. How do we get the adjoint matrix? Interchange these two. That's what we have done here. Interchange those two. That's what we get. So interchange these two to get that. All right. And after we interchange those two, leave these two where they are and change the sign of each of them. So this -1 becomes +1, and this 2 becomes -2. All right. Hope everybody can see that. Anytime you don't understand something, let me know. So that's how we get the adjoint. So basically now, when you're dividing each of these by -1, is like you're basically changing the sign of each of the values in there. Simple as that. All right. So you're changing the sign of each value in there. And so you end up with that. 3, -1, 2, -1. So this is now my M to the minus 1 matrix. This is now my M to the minus 1 matrix, which I'm going to use right there. All right. I'm going to use that matrix right there for my M to the minus 1. And so the equation that I have becomes this equation. This equation now becomes that. This equation becomes that. Right? The A, B, C, D becomes the M to the minus 1 in front times this, times that. All right. And then what do we do? Carry out the multiplication in a normal way, where we use the rows of the first matrix times the column of the second matrix and multiply them the normal way. I'm not going to the steps now. We focused on that yesterday. right? You multiply them like that, and you end up with that matrix when you multiply them. All right, multiply with, you get that matrix. And what it therefore means is that the A is equal to -6, the B is equal to -1, the C is equal to -4, the D is equal to -1. So those are your values. All right, are there any questions at this stage? Are there any questions? Are they okay?
Yes, sir.
All right, good.
Yes, sir.
Yes, sir.
All right, good. So we're gonna practice some of them. So don't
Oh,
rest
sir.
it. Yeah.
Understand. I do understand.
Ah?
I do understand. I do quite understand.
You don't quite understand.
Oh,
All
sir.
right. All right. All right. We could continue. I'm gonna do some examples, and then we'll do the examples. You'll maybe see. I'm gonna show you the basics. I'm gonna show you the basics over here again. If you have a matrices equation, like have a matrix times another matrix equals another matrix. And let's see this one, you don't know the values on that one. You're trying to find that one. Then a simple matrices transposition is that this matrix B that you don't know will be equal to the inverse of matrix A times the matrix C. And so you have to calculate the inverse of this matrix to use it here. And when you work out this side, you will know what the values of A are. It's as simple as that, and it's not complicated, believe me. It's not complicated. It is using the inverse matrix to solve the equation. All right? Simple as that. Let's look at it again. All right? If you have a matrices equation like that, A times B equals C, and the B is the one that you don't know. This is the unknown. The B is what you don't know, and you're trying to find B. To make B the subject is like you multiply the inverse of A over there. Essentially, what we said is that you actually multiply both sides by n to the -1. That's what you're doing now. But these two really equal to the I matrix, where the I matrix is really like a 1. Really like a 1. So it's almost like you're saying 1 times B equals B. So the B becomes A to the -1 times C. That is what happens theoretically. But the shortcut way is to say, if A times B equals C, and you're trying to find B, then the B is equal to A to the -1 times C. If the B is what you're trying to find. Now look here. If the A is what you want to find, if the A is the unknown, then the approach is different, but I don't want to deal with that part yet. I wanted to understand this first, because this is what they mostly set in exam. So if it was AB equals C, and the A was your unknown, then is a B you need to get rid of. What would happen is that you'd have to multiply the B to the -1 beside it here, and so you have to multiply the B to the -1 on this side here. And then these two will be equal to I just the same, and so the A will be equal to C times B to the -1. But don't worry about this yet. Don't worry about this yet. All right, I want you to lock this in a brain first. This one, lock this in a brain first, because 99.9999999% of the questions is application of this one. So let's master that first, and then I'll deal with the little variation of it. We'll understand that one first. All right, so I'll deal with that other variation later. All right, the variation actually appears on the CXC specimen paper, but they have never set it in an exam. All right, they have never set the variation in an exam. So we're focusing on what they normally say first. Master that first. And then when we master that, then we can look at the variation. All right, and when you understand this better, then we look at the variation. So basically, that is all you're looking at, really. That's what using inverse matrix to solve the equation is all about. All right, that is the bottom line of it. So you have to use the inverse matrix. You have to find the inverse of the matrix A to use it here. Remembering that the A to the -1 now will be equal to 1 over the determinant of A multiplied by the adjoint of A. You're telling yourself that you don't understand, man. Believe me, it's simple. So you have to calculate the inverse of this matrix here and use it back there. So, all right, and this is how you calculate the determinant, the inverse. 1 over the determinant times the adjoint. You're gonna see, man. We're gonna do some examples, and you see that it's really very easy. Trust me, you're gonna see it's really very easy. You see, if you had a more specific question, I would have answered, but you say you just don't understand. So let me just continue, And I know, I'm confident, but by the time we do a couple examples, you'll see right through it. Like very simple. All right, so I'm going to continue. All right. Now, one of the things that they like to use inverse matrices method to do is to solve simultaneous linear equations. They set a lot of questions on that, and it's prominent on your syllabus. Maybe 50% of the matrices question, or maybe 60% of the matrices question that you get in exam, right, in CXC, especially when they appear in section 2. Usually it comes at the last question, one of the last questions on the exam paper. This is one of the things that like 50 or 60% of the time, this is what they want they tell you to do. Use a matrices method to solve simultaneous equations. And it's basically an application of this same thing. We're going to use the inverse matrix. So let's look at it, and we're going to practice some questions, and you see that it's really very simple. All right. So let's do it by an example. Let's do it by an example. So let's say we have those two equations to solve simultaneously. But the question tells us to use a matrices method. All right, guys, let's get back to it. Right. All right. So back to the simultaneous equations that we use in a matrices method to solve. All right. So pay attention, everybody. Pay attention. Everything important. Now, when you get a pair of simultaneous equations to solve using a matrices method, there are certain things I wanted to ensure that you look out for first. Now, I've never seen an exam question where they actually set it up a way where it is different as from it appears now, but I still want you to pay attention just in case it happens. Now, you must always ensure that the equations are written like this, where the x value comes first and the y value comes second, and then the number is on the right side, the constant is on the right side in both equations. X value comes first, y value comes second, and then you have a constant on the other side. Always ensure that you have the x followed by the y, x followed by the y in both equations. CXC always set it up like this, you know. But just in case one of them decide not to set it up like this, I want you to know that it must be set up like this. So for example, suppose I gave you instead y plus 2x equals 7, and then they give you 5x minus 3y equals 1. I want you to know that this one is not in a friendly order. You need the x value to come before the y value, everything important. So what you would have to do, you would have to, oh Lord, this thing stuck. Let's see. Oh, I took off the erase. Right. What you would have to do, you would have to take this one and rearrange it and write it as 2x. You'd have to write it as 2x plus y equals 7 if they gave you that. Okay, you must have the x values first and the y values second when you write the equation. Everybody understand that? That's the first thing I want to always to look for. As I've said, I've never seen where they give it other than in this order, you know, in exam, you know. They always give it in this order in exam so far, you know. But just in case they change it, right? Just in case they change it on your exam, I want you to look out for it. Just in case, just to make sure. All right? So, everybody understand that? Just want to make sure everybody understand before we move on.
Yes, sir. No, sir.
You don't understand that? Who said no? Listen, simply, all I'm saying, the two x values must come first in the two equations, and the two y values must come second in the two equations. That's all I'm saying. When you get the two equations, use a matrices method to solve it. Make sure so the x value come first and the y value comes second, and the x value come first and the y value comes second in two equations. What is in that not to understand? That is simple. Get me? So if them put the y value first and put y plus 2x equals 7, you have to change it around and write 2x plus y equals 7. Then you put it with the 5x minus 3y equals 1. And you throw that one and work with these two. That's all I'm saying. Make sure that the x value comes first and the y value comes second in two equations. I'm going to show you why that is important just now. Understand that now?
Yes,
Understand
sir.
that now? Good. Sometimes I have to shout for to get it in. So don't let me shout in as a, don't make me shout in, make you stop ask questions. And ask the question the same way. Sometimes teacher just have to shout. So it go in your brain and you hear it better when you shout. And sometimes we start calm and easy and you don't hear. So sometimes we just have to shout. Just like when we have children, sometimes we have to shout at the children for them to hear the instruction they're trying to give them. And when you try to tell them it's calm and easy, they don't hear. So don't let my shouting turn you off. That sometimes in class we just have a shout, I'm not gonna hear it good, and sometimes we just get angry, but I'm not really angry. Just want to make sure say you hear me good. All right. So don't take that for anything. So anyway, let's continue. So when we form the matrices equation, after we ensure that is x followed by y in the two equations, the matrices equation is very easy to form because you're using the coordinates, you're using the numbers in front of the x and the y to form the matrices like this. That's what it is. So how do we get those values in the 2 by 2 matrix? Let's look at it. How we get those values? The 2 comes here. The number in front, the y, is actually imaginary 1 enough. There's no number in front, then it's really a 1. So that 1 goes here. Then the 5 goes here. And this -3, obviously this time, -3 goes there. That's how we get the value. But understand that. So remember, when there's no value in front, the y like this one now, it's like there's a 1. And so that's why that is a 1. You cannot put any letter, you cannot put any variable inside this matrix. No. This matrix must have only values in it. Tell me if you don't understand that. But understand that. And
Yes,
then
sir.
now,
Yes,
all
sir.
right.
Yes, sir.
Then now, the reason why you must have x followed by y is because you're multiplying it by a xy matrix, which have x followed by y. Right? Such that if I was to expand back this matrix, this side is going to come back to this. Look at it. If I were to expand it back, I would get back these two. Okay, remember, let me just show you this one time. This 7, remember, is equal to, this 7 is equal to 2, 1 times xy is what is equal to this 7. So it's 2 times x plus 1 times y, which is y, equals 7. So you get by the first equation. And the other one, let me use a different color for the other one. Let me use the blue. The other one, which is the 1, the 1 is equal to the second row times the column, is the 5 and the -3 times the same xy. See, that's why I have to have x followed by y. That is equal to 1. And it will be the 5 times the x and the -1 times the y, which is -3y. That is equal to the 1. And you see that this now is the same second equation. That is why you have to make sure that both of them have the x value first and the y value second, because you're using the same xy matrix for that as you're using for that. All right? And that is why you have to do it that way. So basically, this matrices equation, if you expand it out, you'll get back these two equations just the same. That's what it is. So you have written the two equations in a matrices form. And it's very easy. The same 7 and the 1 form back this matrix. The x and the y form is there. And then the values here and here form that one. So I can set up one easy over here and show you now. Another example, a random example. Look at this random example I'm going to do over here now. So I have -3x plus 5y equals 2, and I have x minus y equals 4. As an example, I'm going to set up a matrices equation. Look now, I have the x value followed by the y value in that one, good. I have the x value followed by the y value in that one, good. Remember now, when no number is in front of the letter, it means that there's a 1 there, and there's a 1 there. So when there's no number, when there's no value in front of the letter, there's a 1. Coefficient is 1. Look, I'm going to set up the matrix now. Easy. I'm going to put by a 2 by 2 matrix. Since I have x followed by y and x followed by y in both of them, my column matrix is xy. Then the matrix over here is the same values, 2, 4, not a fraction, it's a matrix, a column matrix, 2, 4. And then the values in here now are the coefficients, -3 and +5, -3, 5, 1 and -1. 1 and minus 1. Important, you have to see the sign in front of the values. You have to put the same sign in front of the values. That's it. You can fast. But understand that. And that's my matrix complete.
Yes, sir.
Good.
Yes,
and then
sir.
my whole aim now is to find this. And what is this now? This is just like my A times B equals C. And I'm trying to find the B. So the B equal. The B we want, which in this case is XY. Let me not write B. The B we want, which is the XY this time, will be equal to the A to the minus 1, where this is my A now. So my A here, this becomes my A now. A to the minus 1 times my C, and my C is 2, 4. So I have to calculate A to the minus 1 from this matrix here. That's my A matrix. I have to calculate A to the minus 1 from that matrix. See it? So let's do it over here now. Let's do it over here now, guys. Let's go. Let's do it over here. Let's do it over here now. All right, with this question. What happens next? Bam. I'm going to call this matrix M. The matrix in front, the XY, I'm going to call it M, just to reference it. So I'm basically calling this matrix M. See it here? M. Calling it M. So like I'm saying, M times XY equals 7, 1. That's what it is. Is that like I'm saying, M times XY equals 7, 1. All right? That's basically what I'm saying. M times XY equals 7, 1. And then I'm trying to make XY the subject. What I do, the inverse of M is going to go in front. See there? The inverse of M is going to go in front of the 7, 1. So XY will become equal to the inverse of M times 7, 1. So I need to calculate the inverse of M now. How do I calculate the inverse of M? 1 over the determinant multiplied by the adjoint. Simple. Bam. See there? The inverse of M that I need to put right up here. So the inverse of M that I need to put here is calculated using this formula. 1 over the determinant multiplied by the adjoint. All right? As simple as that. That's how I calculate my M. So I'm going to calculate it now. See there? 1 over -6 times -5. How do I get that? Leading diagonal minus trailing diagonal. Let's put it down. Let's use a blue ink to show it. So how do I get the -6 right here? -6 minus 5. See here? This times this. Leading diagonal product. The 2 times -3 give me -6. All right? And then now, the -5. The -5 is not -5 in there, it's really -5. It's really -5. So it's minus 1 times 5. 1 times 5 is this 5. So -6 is the first product. -5. -5 is the second product. So let's erase everything. Let's erase everything. So I'm putting by the M right here. All right. And I'm saying this value right here is the 2 times -3 minus 5. Minus 5. That's my determinant. But I understand how I get my determinant there.
Yes, sir.
Good. And then for the adjoint now, I'm interchanging the 2 and the -3 to get these. Interchange them to get that. So I interchange these 2 to get that. Interchange the 2 -3 and I get -3 2 on the leading diagonal. And then on the following diagonal, I'll leave them where they are and change the sign of both of them. So the 1 becomes -1 and the 5 becomes -5. I don't interchange those two, I leave them where they are, change the sign. And basically that's how I get my M to the -1. Right? That's how I get my M to the -1. Right? That's my M to the -1. All right, that's my M to the -1. Let's simplify it. So it becomes that the -6 and the -5 is -11. Now, usually, when you're going to multiply, I remember now, what's going to happen now is that this is your M to the -1. It's coming right here. I multiply by the 7, 1. But usually what you are told is leave the fraction out here for last. Don't multiply in the fraction yet. Leave the fraction for last. So that way, you're multiplying this matrix with the whole numbers by this matrix first. Leave the fraction for last. All right, let's look at it. So when I put it there, see, I leave the fraction for last. Let's look at it, guys. So this M to the -1 that was here. I put the m to the minus 1 right here. Because that's my m to the minus 1. That's it here. But I'm leaving the fraction for last. So that's where my m to the minus 1 was, up there. But understand that? And then I'm going to multiply the values. I'm going to multiply the values first. To multiply the values now, I'm going to multiply these two matrices first. Leave the fraction for last. How do I multiply those two matrices? Rows of the matrix times the one column. Rows of the matrix times the one column. I spent a lot of time on that yesterday. So let's just show what the result would be when you multiply them. Bam. That's what you're going to get. How you get that? -3. Let me show you quickly how you get that quickly. It becomes -3 times 7 is -21. And -1 times 1 is -1. -21 and -1 give me -22. That's how I get the -22. All right. Next one.
Again.
Remember, you multiply along the row down the column. First element by first element, second element by second element to get this one. Don't want to spend any time on this, you know. The -3 times 7 is -21. Along the row, -1. Down the column, 1. -1 times 1 is -1. -21 and -1 give me -22. That's how we get the -22. For this value down here, the second value, it is this row times the column. Give me that value. -5 times 7 is -35. And then the 2 times 1 is +2. -35 plus 2 give me -33. That's how we get the -33. We're multiplying just as we did yesterday. I told you to practice the question that we did yesterday. All right. And then you realize what happens, that these values in here are perfect multiples of the -11. That's what usually happens. 99% of the time, that is what happens. Every now and then you get a question where you actually end up with fractions. But most of the times, these questions work out to be whole number answers like this. All right? Because if we divide this by -11, we get 2. And if we divide this by the same -11, we get 3. So what it means, therefore, is that this matrix equals this matrix. And therefore, the x equals 2 and y equals 3. X equals 2, y equals 3. And they normally write that. Because the question usually asks for the values of x and y. X equals 2, y equals 3. So you don't leave this as the answer, you know. Don't leave this as the answer, guys. Don't leave this equals this as the answer. You have to write this as the answer. You have to write out the values as the answer, because that's what you're trying to find. The value of x and the value of y. So don't leave the matrix as the answer. All right, we're going to do more of these questions. They say it's the same thing every time. All of them is the same thing. Almost every time they set one of these questions, it's the exact same procedures. Same procedure every time. All right, so I'm not going to do any more yet. We're going to do some examples. Let's move on and try to finish the note. Then we're going to practice some questions and put it all together. All right, all you need to do, students, is go home, or you're at home after the class, work the same exact questions again. That's all you have to do. Before you do the other examples that you're going to get as homework, work the same examples that I do in the class. These examples that I'm doing, work them over by yourself. Because you have the solutions, work them by yourself, understanding each step as you go. Right? If you have a problem, you can send me a little message. Right? Watch over the video. Look back at the explanation that I'm giving. Work the questions yourself. After you're comfortable that you have worked the questions yourself and you understand what you have done based on the video watching over, the solution that you have, what have you, then you go and you try the other questions. Same thing. If you have a problem, send me a message. If you have a problem working on, send me a message. Believe me, if you do what I tell you, these things will become very, very easy for you. Very, very easy. If you just do everything that I tell you to do. Don't miss out nothing. Do every single thing I'm going to tell you to do. And these things will become very easy for you. All right? So anything will look hard now, it's because you don't know yet. They're actually very easy. We have to put the work in for them to get easy for you as well. You can do them things and I'm asleep, you know. I'm asleep, you can do them questions, you know. I'm a deep, deep sleep. I can do these questions. Because them so easy. So me can do them in my deep, deep sleep. You know, most can do them in your awake. Come on, man. You need to get to the stage where you can do them in your sleep too. And that's what we're working towards. I want all of my students to be able to do these questions even when they're sleeping. In your dream, you still do it and get it right. All right, so let's continue. So next thing we'll look at now is singular matrix. All right, and because we have already now dealt with the inverse matrix, we can talk now about a singular matrix. I think this is the last thing before we start doing some questions. Sorry about that. So a singular matrix is a matrix that has no inverse because the determinant of the matrix is equal to 0. All right, that's the definition. A singular matrix is one that has no inverse because the determinant is equal to 0. Everything important. Let me stop from now and tell you how everything important. Sometimes the question will tell you that a matrix has no inverse. If the question tells you that it has no inverse, you must know that that means that it is singular. I must also know that that means that the determinant is 0. Some other times, a question will tell you that the determinant is 0. If the question tells you that the determinant is 0, you must know that that means that it has no inverse. And also, you must know that it is singular. If the question tells you that the matrix is singular, you must know that the singular means that it has no inverse. You must also know that the singular means that the determinant is 0. So any one of those three things that tell you, you must know that it means the other two. Any one of those three things you're told, you must know that it also means the other two. And CXC will test your knowledge of that. So if them tell us that the matrix singular, you must know that it has no inverse and the determinant is 0. If them tell us that the matrix has no inverse, you must know that it is singular, it's a singular matrix, and you must know that the determinant equals 0. If them tell us that the determinant equals 0, you must know that it is therefore singular and has no inverse. For the purpose of your calculation, this is what you're using. That the determinant is 0. That's for the purpose of your calculation. For the purpose of answering certain questions that they might ask you, that information is still relevant. So I don't want you to focus on the fact and the whole business of singular matrix. This important and this important equally. All three of them important equally. So I don't want you to forget any part. So if I ask you what is a singular matrix, you have to tell me that it has no inverse. You have to tell me that the determinant is 0. If I ask you what is a matrix with no inverse, you have to tell me that it is singular. I have to tell me that the determinant is 0. If I tell you that the determinant of matrix is 0, you have to tell me that, okay, that matrix is singular and it has no inverse. So any one of the three you know, you must automatically know the other two. Everything important. But understand that? Before I move on, everybody understand that? These
Yes,
three
sir.
things. Good.
Yes, sir.
All right. So much time I spend on talk about that. I don't want any foolishness when we get to classwork Wednesday now. All right. So sometimes a question they give you a question and don't mention not about singular. All they tell you is this. And you must know so the singular matrix they're dealing with. All right. We don't talk about that now. All right. So that is it. So if the matrix is singular, then the determinant is equal to 0. And that's, as I said, that's a part of it that you use for the calculation, that the determinant is equal to 0. And how does that work? It means that what would normally give you the determinant is the leading diagonal product, this times this, give you that, minus this times this, give you that. When you subtract them, that will be equal to 0. Another way of saying it is that the leading diagonal product is therefore equal to the following diagonal product. When the two diagonal products are equal, the matrix is singular. It has no inverse. All right. So anyway you want to look at it, that's what you do. You normally use that. The determinant and put the determinant equals 0. All right. Let's look at why that is so though. Let's look at why that is so. There's no inverse. When the determinant is 0, there's no inverse. Let's look at why that is so here. Now, remember that the formula for calculating the inverse is 1 over the determinant multiplied by the adjoint. I hope somebody see it already. Why if the determinant is 0, it has no inverse? Why is that? Because if the determinant is equal to 0, then in calculating the inverse, remember, in calculating the inverse, we have to put 1 over the determinant. So if the determinant is 0, then we'll be calculating right here 1 over 0. And what happens, remember, when you divide by 0, your result is undefined. Remember, when you divide by 0, your result is undefined. We cannot divide by 0. So the 1 over 0 part in the calculation of the inverse, the 1 over 0 part of the calculation of the inverse would be undefined. And so this whole thing can work out. You can't work it out. Cannot work out. And therefore the matrix, the inverse matrix that you're trying to find would not exist. It would not be real. It would not exist. It would be undefined. And that's why we say it has no inverse, because you cannot calculate 1 over 0. So when the determinant is 0, you can't do a part of the calculation here. So you're not able to do this part of the calculation in calculating the inverse matrix. And that is why it is undefined. All right, that is it. Anybody understand that? That is why the m to the minus 1 is undefined and it does not exist. And when there's no inverse, we say that the matrix is singular, standing alone. It's like, married. It is singular. The matrix is singular. It has no inverse. It is singular. It has no inverse. And it has no inverse because the determinant is equal to 0. All right, and remember, has no inverse means that it's singular, determinant equals 0. Determinant equals 0 means it's singular and has no inverse. Singular means that it has no inverse and the determinant equals 0. 3 things that mean simultaneously with singular matrix. Any questions there? Very good. So not only do you know why the singular matrix is singular, you understand why it is singular. Simply because we cannot divide by 0. And when we're calculating an inverse matrix, we have to divide by the determinant. So if we're dividing by the determinant and the determinant is 0, we will get an undefined result because we cannot divide by 0. There's no value that we. All right, students, sorry about that. All right, so most you can do now are a couple of examples, right? So let's do a couple of examples now. So the examples on the slide right here. That's the first one. So given that matrix is a singular matrix, find the value of K. And it's very simple. If it's a singular matrix, it means that it has no inverse and the determinant is equal to 0. Let's see what the solutions are first. It has no inverse and the determinant is equal to 0. So don't put in that it has no inverse, because that is important. So it's singular, meaning it has no inverse. I don't want us to forget that part at all. And the determinant equals 0. So the determinant equals 0 part is what you actually use to calculate, to do your calculation. And so all you do, you write an expression for the determinant, which is the 6 times the 2 minus the 3 times the K. That's what we have done here. And put that equals 0. All right? Put that equals 0. And we'll put that equals 0. We end up with K equals 4. All right? We'll solve that for K. K becomes equal to 4. And as simple as that, we can work it out. All right, let's look at another example. Another example, it says, show that this matrix is non-singular. All right, so I'm going to say what we're thinking now. If a matrix is singular when the determinant is equal to 0, when is it non-singular? Somebody answer and tell me.
Sir,
If it is
up 0, sir.
When it what?
Has a value of more than 0, sir.
No, it have to be more. Just a value that is not 0. Because remember, determinant can be positive or negative. You know? So once the determinant is not 0, it is non-singular, meaning it has an inverse. So the only time the matrix is singular is when the determinant is equal to 0. So once the determinant is not equal to 0, it means that it is non-singular. A non-singular matrix now is one that has an inverse and the determinant is not equal to 0. So this question, all we need to do is calculate the determinant and show that the determinant is not 0. That's all we have to do. Let's look at it. See there? The determinant is 4 times 2 minus 1 times negative 2. 1 times negative 2 becomes a positive 2. So 4 times 2 is 8. 8 plus 2 is 10. See there? The determinant is 10. And 10 is not equal to 0. And therefore, the matrix is non-singular. It has an inverse. All right? So the matrix is therefore non-singular. Non-singular. And therefore has an inverse. Yeah? A to the minus 1 exists. So A is a non-singular matrix simply because the determinant is not equal to 0. So A to the minus 1 exists. And that is it. All right. So watch me now, guys. Watch me now. I'm going to show you something now. All right. So that's your homework we're going to look at. But the homework is in your handout. All right. So let me show you what we're going to look at next now. All right. Let me show you what we're doing now. Let's close this and I'm coming back on that. All right. We're going to do some questions, right? But before we go to the questions, I want you to look at something that I want you all to pay keen attention to. All right. Pay attention. Matrices. Must know. So this guy right here, so I'm bringing up on the screen now. You all have it in your handout. Matrices must know. Let me turn it. I'm going to have to turn it the other way for it to come up. Look at it. I want you to take some time on this sheet. This sheet basically covers everything that we have done or that you need to know in matrices. Like summarize everything that we have done. The main thing. See, talk about singular matrix, everything. Identity matrix, the I, the M times M to the minus 1 equals I, the addition, the multiplication, the everything. So you can use this as a quick revision. These are the things in matrices that you must know how to do. Remember, you know, the topic that we're going on Sunday, you have to know everything about matrices in order to do that topic. You can't do that topic without an in-depth knowledge of your matrices. So this is a must-know sheet. Everybody must study and know everything on this sheet. If you know everything on this sheet, then you'll be able to do any matrices question. Everything on this sheet. Right? The only additional thing that is not on this sheet that I wanted to remember is, for example, when the matrices multiplication is possible. That's the only thing that is not here. You remember, the matrices multiplication is possible when the number of columns in the first matrix is equal to the number of rows in the second matrix. I would write that on this sheet as well. Put it on the bottom or something when it is possible. And also that matrices multiplication is non-commutative. Matrices multiplication is non-commutative. So for example, in matrices, AB is not equal to BA. Mute your mics, please. Mute your mic. AB is not equal to BA, for example. All right, so everybody, you have this in your handout. Spend some time and study it. All right, some person who do have the handout, I sent it to you on WhatsApp. So spend some time and study this. Add to it that the matrices multiplication is possible when the number of columns in the first matrix equals the number of rows in the second matrix. Remember, the resulting matrix of multiplication will have the same number of rows as the first matrix and the same number of columns as the second matrix. And remember, matrices multiplication is non-commutative. All right. So that is it, guys. So we're gonna do some questions now. Okay. I'm gonna do some questions now, guys. Some questions. Because more maths equals better maths. All right. So let me see. All right. So let's find the questions here. May 2016, the first one I want us to do. Okay, so there's a question on this that I want us to do. See, this is an exam paper, right? Everybody can see that? It's an exam paper. So I'm going to show you a question on it now. It's down at page 29. All right, page 29. See there? That's a matrices question right there on the exam paper. I can actually do it right there on the paper too, you know. Let's do it right there on the paper. Everybody can see it?
Okay.
Good. So this question here says, determine the value of x for which the matrix, that matrix is singular. That matrix is singular. What do we know? Let's go straight into it, not hesitating. If that matrix is singular, it means it has no inverse. And when it has no inverse, the determinant is equal to 0. And this is what we use for our calculation. So we're going to write the expression for the determinant. The determinant will be 3 times 4 minus 2 times x, which is 2x, equals 0. That is the determinant. Now this is 12 minus 2x equals 0. Means that 2x over here equals 12. Divided by the 2, we get x equals 6. i.e., x will be equal to 6 if the matrix is to be single. You can look at it and remember, you want the 2 diagonals to be equal. So that and that are 12. So in order for this and this to be 12 too, the x have to be 6. X have to be 6. And you could work it out that way as well. That is the answer. Quick and fast. 2 free marks, quick in an exam.
So, sir, what would
Huh?
I know that you don't necessarily have to put all of the work, you know, to get a 2 marks, sir.
Exactly.
So would it have just been like what's directly?
No. If you see it from right here, so and that's right, x equals 6 from right there, so you're good. Get your marks.
Yes, sir.
The important thing is this. You see the question, tell us the determinant equals 0, you know. You just tell us it's singular. So by you putting this, by you knowing that, you already get a mark. By you showing the singular equal that, you already get a mark by putting that. All right? So that is it. All right, let's move on to the next part. The next part down here now gives us those 2 by 2 matrices, N and P, and they say must calculate N times P. We must calculate N times P. So we're going to multiply them. N times P. Let's put it here. N times P equals 4, 1, 3, 2. Mute your mic, please. Mute your mic. 1, 5, 2, 1. Now remember, we're going to get one big 2 by 2 matrix. All right. You should have studied and know all these things from yesterday. Remember, you're multiplying the rows of the first matrix by the columns of the second matrix. All right. So we'll do the multiplication again. First value, you want to get 4 values. Here, 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 here. For this value here first, the first value here is in the first row and the first column. So we're using this first row and this first column. First element by first element, second element by second element. So it's 4 times 1 and 1 times 2. 4 times 1 and 1 times 2. Give us that element. 4 times 1 is 4. 1 times 2 is 2. Done. That gives us that value right there. That value is 6. I'm going to write the final answer down here. So 6. All right. Second element now, right here. Second element right there is in the first row and the second column. So it means that to get that element, we use this first row with this second column. This first row with this second column. 4 times 5 and 1 times 1. First element by first element, second element by second element. 4 times 5 and 5 times and 1 times 1. 4 times 5 and 1 times 1. 4 times 5 is 20. 1 times 1 is 1. Let's put this a little bit more over. Make it wider. Right, so it's 20 plus 1. 20 plus 1. So that value is 21. Then the element down here is in the second row, first column. Second row, first column. So we use this second row with this first column. So it's 3 times 1 and 2 times 2. First element by first element, second element by second element. 3 times 1 is 3, 2 times 2. Oh, sorry about that. Right. 3 times 1 is 3, 2 times 2 is 4. So that value becomes 7. And then the last value here over here now is in the second row, second column. Second row, second column. To get that value, we use this second row and this second column. First element by first element, second element by second element. 3 times 5, 2 times 1. 3 times 5, 2 times 1. 3 times 5, 2 times 1. 3 times 5 is 15, 2 times 1 is 2. 15 plus 2, putting it at the wrong place. All right, so that's it. So that 15 and 2 is 17. Done. That's the answer right there. Answer. Next part says, given that Pn is equal to this, so they're helping us. Given that Pn is equal to that, determine whether matrices multiplication is commutative. Answer is no. So you're going to say since NP is not equal to Pn, put the not equal to sign. Right? Since it is not equal, then the matrices multiplication is not commutative. Right? So the answer is that it is non-commutative. Answer is non-commutative or not commutative. Same thing as none. None are not. Same thing. Right? Non-commutative. If I write it out and say, since NP is not equal to Pn, matrices multiplication is non-commutative. The answer is that it is non-commutative. I just write it like that. 60 will give you the marks. And then once them see you write non-commutative, they'll give you the marks. All right? Since NP is not equal to Pn, the answer is that it is non-commutative. So far, so good? Very good? Next part down here.
Yes, sir.
Good. Next part down here is to calculate n to the minus 1. Let's write down what n is again. What was n again? N was 4132. Let's write it down here. N is 4132. And now down here now they want us to calculate n to the minus 1. See there? N to the minus 1. Well, n to the minus 1 equal again. N to the minus 1 equals 1 over the determinant of n multiplied by the adjoint of n. ND. Adjoint is with a ND. D means diagonalize. Ready? 1 over the determinant. What's the determinant? This product minus this product. 4 times 2 is 8. Minus 3 times 1 is 3. Multiply by the adjoint. Interchange the elements on the leading diagonal. Interchange those two. 2 go up here, so 4 go down here, so. Leave these 2 where they are. Change the sign. Leave them where they are. Change the sign. -1, -3. Simplify this. 1 over 5 bracket 2 minus 1 minus 3, 4. Minus 1, 4. Minus 1, minus 3, 4. That's it. And we can divide each value by 5 and write something like this. You can write something like this. 2/5 minus 1 over 5 minus 3 over 5, 4 over 5. You can get them something like that. Just to make it fit. I don't really like write fractions with a slanted thing like that, you know, but this case, because I'm not using it to do anything, I can leave it like that. But that is it. If I'm going to do any calculation with my n to the minus 1, I'm going to use this with a fraction outside. If I have to use my n to the minus 1 anyway, which usually is the case. They don't usually ask to find n to the minus 1 and don't ask to use it. Which is what they are doing here. See? Look down here, so now. Them say, hence. What hence mean? Hence mean use this thing where them just ask you for. That's what hence mean, you know. Use that. Hence, calculate the value of xy. So what it is, we're trying to find xy. Note that this matrix really is our n matrix. So this matrix really is n. This is really n. That is really n, you know. So what do we know? The xy that we want is going to be equal to n to the minus 1 times 1, 2. You must understand it now. The n to the minus 1 come in front there. Simple matrices transposition. That's it. So I need to put my n to the minus 1 matrix here. This is n to the minus 1 that I'm going to put right in front there. Leave the fraction for last. Don't work with this one. Because you're gonna be working with those 1/5, 2/5, 3/5 and mess it up. Leave the one with the fraction for last. So see this calculation here, and I'm gonna put this calculation here. So now, so my xy becomes n to the minus 1. I'm using this as my n to the minus 1. So I put 1/5 bracket 2 minus 1 minus 3, 4. And I'm multiplying that by the 1, 2. 1, 2. But understand that this is my n to the minus 1 in front of the 1, 2. Leave the fraction for last. Work out this part here. So first, how do I work out that part? Same thing. Rows of the matrix multiplied by the 1 column. Only 1 column. Rows of the matrix times the 1 column. Ready. So xy, run out of space. Run out of space. Let's write a little smaller so we can make sure it fits. So xy equals, leave the fraction for last, 1/5 times, what am I going to get? Remember now, first value is this row times the 1 column. So it becomes 2 times 1 and minus 1 times 2. See here, this row times the 1 column, give me my first value here. 2 values I'm going to get, First value here is those 2 multiplying together. First row and the 1 column, right? So it's 2 times 1 and minus 1 times 2. So what do we get? 2 times 1 is 2 and minus 1 times 2 is minus 2. Then the second value going here is this row times this column. Minus 3 times 1 and 4 times 2. First element by first element, second element by second element. Always first element by first element, second element by second element. Minus 3 times 1 is minus 3 and 4 times 2 is 8. What that becomes? That becomes 1/5 bracket 0, 5. And so it becomes 0, 1. Because this divided by the 5 is still 0. 5 divided by 5 is 1. What that means? That implies that x equals 0, x equals 0, and y equals 1. Y equals 1. That's my answer right there. Any questions there? This is my answer. Any questions there? Very good?
Yes, sir.
All right, nice. We shot to that. We want to shot to another one now. Fast and furious. Let's shot to another one fast. All right, which one we'll go for now? Let's go for another one now. Let's go here and find another one. We're gonna do this one. More maths equals better maths. All right, put this one side now. This one over here now. So another example. Pure example paper, me I go to now, Exam paper like dirt. All right, so we're on to question 11. There's a question 11. Slide down here, so. Question 11 we're looking for now. Question 11. See here, question 11. See that? Bam. It says the following sum, write the following simultaneous equation in a form. Write the following simultaneous equation in a form. Ax equals b, where a, b, and x are matrices. In other words, I want us to write this as a matrices equation. 2 marks to do that. Soft. Exam paper, this, 2 marks to do that. Just write this as a matrices equation. What do you do? What do you do? Make sure you have x followed by y, yes. X followed by y, yes. That's what you have. Then you're going to write the matrices now. See here, bam, this is the answer. A 2 by 2 matrix times xy equals the values, -1, 6. They put the coefficient of the x and the y up here. Easy, no negative, no there. And no, all of them have values in front of them. So it becomes 3, 2, 5, 4. Done. That's your answer right there. You have written the equations in a matrices form right there. Done. Quick and fast. Full marks for that. 2 marks for that. Easy. Rectify that properly. Rectify that. Good. And this is 4. That's the matrices equation you have written there. But understand that? So far so good?
Yes,
Next
sir.
part.
Yes, sir.
Next part now, use the matrices method to solve for x and y. So they want us to solve this now, you know. Want us to solve this. But we know what's going to happen. This is going to lead us to say xy. We're going to write it nice now. Xy equals, what is now? It equals the 3254 to the minus 1. So we have to step up the ante now. Times the negative 16. Tell me if you understand that. This matrix comes in front here to become to the minus 1. So when I work out, this means to the inverse. So it's another way of writing it. So instead of calling it a letter, I could have called it A, you know, and put A to the minus 1 here, so you know. But we are short the work, so just put the minus 1 on it, same way, right here. So we have to work out that inverse right there. But understand that? I'm going to work it out now. But understand that so far? Don't want to move to understand that.
Sir.
Good. I'm going to work out this. Good. So this equals 1 over the determinant. You know, this equals 1 over the determinant. What's the determinant? This product minus this product. So the leading diagonal product is 12 minus the following diagonal product is 10. Good. Multiply now by the adjoint. Multiply by the adjoint. Still, this is just working out, you know. Interchange these two and the leading diagonal. 4 up here, 3 down here. Leave these two where they are. Change the sign. -2, -5. That's my inverse, you know. And I'm multiplying that now back by my -16. -16. Right? So see there, -16. I'm underline about this. So all that I've done right here, put this in red and show you. Right? This matrix that I'm underlining with the -1 up here is just this. That's it. That matrix to the -1 is this matrix that I worked out. 1 over the determinant times the adjoint. And I multiply back by the 16. What do we do now after that? Work it down, quick and fast, nice and easy. Equals, this is just 2. Leave the fraction for last. 1 over 2. Multiply them two matrices here now. Or multiply them again. Rows of the first matrix, multiply by the 1 column. Rows of the first matrix times the 1 column. We're going to end up with a column matrix there. Bam. So this is this. Leave that for last. We're doing the calculation of these two now. Ready. We're going to get a column matrix with 2 values. The first value here is this row times this column. First element by first element, second element by second element for the first value, doing the first value first. So it's 4 times -1 and -2 times 6. 4 times -1 and -2 times 6. 4 times -1 is -4. -2 times 6 is -12. But understand that? But I give it that?
Yes, sir.
Good. Then this value down here now is this row times the 1 column. First element by first element, second element by second element. First element by first element, second element by second element. -5 times -1 and 3 times 6. -5 times -1 and 3 times 6. -5 times -1 is +5. And 3 times 6 is 18. Note it, 3, 6 are 18. 18. So this becomes half of, this works out to -16. -16. This works out to 23. 23. So the answer works down to, bracket works down to -8. Half of 23 is what? 11.5, don't it? 11.5. So based on that, we can write the answer. We can put the answer in a different color so we can see it. So we can say, therefore, x equals -8 and y equals 11.5. That's it. Soft. Question I don't know. You don't ask nothing else for me to see. That's it. That's it. That's an exam question right there. 6 marks to do that in the exam. Are they good?
Yes, sir.
Good. More maths equals better math. Remember, you know, all these questions that I'm doing, you know, I want to do them over, you know. So when you watch about the video or whatever, you're going to write down the question and write them over by yourself, you know, every single one of them. So I'm going to do as many as I can do before I finish. All right, let's go now. So going on to another paper now. More maths equals better maths. All right, let's find another one now. Bam. So another one is, let me see now, another one. Let me see now. We're gonna do one on this paper now. Given that this is 2019 now, it's last year now. So you see me I do some old one and I do some new one. So you see that all them they're all the same. When them set them long time or them set them in recent time, they're all the same. Don't matter. All right, so we'll find a question on this paper now. Where is it? Let's find it. Matrices question is somewhere on this paper. Usually when I like question 11, question 10, somewhere around this one. Let's go. Matrices. See the bam. The matrices. Right, here's a matrices right there. See there? Matrices question that. Soft. 3 matrices are given by that. P is that one, Q is that one, and R is that one. 3 matrices. But I can see them. All right. Question says, use a calculation to support your answer. Using a calculation to support your answer, explain whether P is singular or non-singular. Remember, if it is singular, the determinant is 0. So all you have to do is find the determinant. So see it your calculation. So straight into it. Determinant, this is the purple. Straight into it. Work out the determinant and see if it equals 0. Determinant of P equals, and it's a use calculation now. So therefore, you cannot just say that it is singular or not singular. You have to show them something. And by you calculating the determinant and say that it is not 0, you are basically telling them that you know when it is singular. So you have to show the working. So the determinant now be this product minus this product. So that product is -5 minus this product is 2 times 0 is 0. That works out to -5. Watch it. Look how you both your upon him now. Watch this now. -5. Oh, look what you're going to know. You put not equal to 0. You see, by you putting that, examiner gear marks. By you putting that, you're saying to him that you know your stuff. The determinant is not equal to 0. Therefore, P is non-singular. It is not singular. Done. Full marks for us doing that in the exam. Right? Full marks for us doing that. Done. Show the determinant is not equal to 0. Therefore, it is non-singular. The determinant is actually equal to -5. You get me?
Yes,
nice and easy. Good. 2 marks for us doing that. Next part says, given that PQ equals R, determine the value of A and B. All right, I can look back at them now. PQ equals R, determine the value of A. Let me see if I can copy this down here. So let me see if I can copy them down here. So let me see. Can I copy them? I can copy my work. Okay. All right. So I can see if we can remember what P equal. P is -1205. Let's write them over. P is -1205. This is P. Q is AB. And R, what is R again? R is 1115. 1115. And now the question is telling us that PQ is equal to R. PQ is equal to R. I must find the value of A and B. Now, A and B is the Q, So really and truly, we can show us so we know our stuff by saying this means that the Q is equal to P to the -1 times R. But understand that? I was trying to find the Q. Q we're trying to find, So by matrices transposition, the Q is equal to the inverse of this in front of the R. That's what we said that we've been doing. Since 6 years, this a lot. So we need to put the inverse of P in front of the R right there. So watch this now. So therefore, the Q which is AB, that is the Q, is equal to the inverse of P now. The inverse of P now, we're going to work out the inverse of P and put it right here in front. Right? So the inverse of P becomes 1 over the determinant. We just worked out the determinant up here a while ago. See here, it is -5. So we don't have to work it out again. 1 over -5. So it becomes 1 over -5 times the adjoint. Interchange these two. So the 5 goes here, -1 goes there. Leave these two where they are and change the sign. It becomes -2. 0 and a sign, so it stays 0. And that is your P to the -1, you know. I multiply that by R. R is 1115. See that? This right here is your P to the -1. This is your P to the -1 that we just did. Let's put it in red. This right here is our P to the -1. And this is our R. And this is our Q. So that equals that. You get me? And then we'll also work that out now. We're just gonna work this out now. Leave the fraction. Leave. We're gonna work out this part first and leave the fraction for last, as usual. So see here now, oh, run into space. All right, see here now, because I'm trying to write big so you can all see what I'm doing, you know. So AB becomes equal to 1 over -5. Leave that for last. And I'm going to multiply this matrix times this matrix now. Remember, you're using the rows of the first matrix. Rows of the first matrix times 1 column. All right, so ready now. 5 times 15 and minus 2 times, no, 5 times 11 and minus 2 times 15. See there, this times this we're doing. So it's 5 times 11 and minus 2 times 15. First element by first element, second element by second element. All right, so it's 5 times 11 and minus 2 times 15. Ready now. 5 times 11, 5 times 11 is 55. Minus 2 times 15 is -30. Then this element second now, the second element here now that we want is this row times the 1 column. Bam. 0 times 11 and minus 1 times 15. 0 times 11 is 0 and minus 1 times 15 is -15. So this becomes 1 over -5 bracket. This becomes 25. 25. This becomes -15. -15. So therefore the AB equals, we wrote this down now. This divided by -5 is -5. -5. This divided by -5 is +3. +3. What that mean? Conclusion. Let's put the conclusion in red. That means conclusion. That means that the A equals -5 and the B equals 3. Done. That's the answer. Question asked about A and B. See there. So you can't leave this as the answer, you know. You have to put that. Answer the question. All right. Next part down here, so now. State a reason why QP is not possible. State the reason why QP is not possible. Why is QP not possible? Anybody can tell me why QP is not possible? Let me write down Q and P. Q and P. Q and P. Q and P. Now Q is, work out Q. This was Q, you know. This matrix is Q, you know. So Q is -5. Write it out. QP. QP would be -5, 3 times P would be, just P again. P was -1205. -1205. And I said that this is not possible. Not possible. And the question I want the reason. Let's write the reason under here so now. Why is it not possible? Somebody tell me. Why is it not possible to multiply them?
Sir, it's not possible to multiply them because they're not commutative.
Nope. Commutative has to do with switching them around. Listen, remember, guys, multiplication of matrices is possible when the number of columns in the first matrix is equal to the number of rows in the second matrix. That is what you're looking for. See it here? Look, this matrix here, so this matrix here, so is a 2 by 1. And this matrix here, so is a 2 by 2. For the multiplication to be possible, the number of these two have to be the same. They are not equal. If you put something like that for the exam, and give the marks, you know. The number of columns in the first matrix is not equal to the number of rows in the second matrix. That's why it is not possible. Because this one is a 2 by 1 matrix, and this one is a 2 by 2 matrix. So the number of columns in the first matrix is 1, and the number of rows in the second matrix is 2. They're different. So the multiplication is not possible. I don't understand that. I know, so you're not going to remember everything. I know you're not going to remember everything. But you must remember this from yesterday, don't it? Don't it?
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir. I don't what I'm gonna say.
Well, say it then, man. Say it. Say it. Don't say that. Go say it. Not possible because number of columns in Q is 1, while number of rows in P is 2. That is not equal. That is, they are not equal. That is, they are not equal. That is why it is not possible. Them two numbers are not equal. The number of columns in the first matrix is not equal to the number of rows in it. And me I draw that. Me I do this for my exam paper too, you know. I am putting that on my exam paper as well. May the examiner see it. I'm putting that on my exam paper. Shows to them not equal. See, put the arrow, see me write this. Not equal. And then write that statement there. So full marks if you do that in the exam, just as I've written it there. Number of columns in Q is 1, while the number of rows in P is 2. That is, they are not equal. That is the reason. That is the reason why it is not possible. For it to be possible, they have to be equal. But understand that? But good?
Yes, sir.
I learn, man. No one said. Yeah? Somebody have a question? Nobody have a question. Nobody good. More maths equals better maths. Let's go. Let's go and do some more still. All right, let's find another paper. P exam paper when I get to there. So the questions in the handout that you have, we're going to work those questions too, right? But we're going to go some different questions that are not in the handout. Right? Some recent exam papers. I can find another one. More maths equals better maths. What time is it now? I'm going to have extra session today. Just 5 o'clock. All right, we can work for another half an hour. That's just 5 o'clock now. So come, let's go. We can work another one. More maths equals better maths. Study hard, pass easily. Study hard, pass easily. You want to pass the exam easy? You have to study hard. Study hard. You want exam easy. I'm going to exam nice. But do exam nice. Yeah, so want the maths exam for nice. You know the hard thing, you know exam. Shut it up. Right? Exam was easy. The way to make exam easy is to study hard. And the more maths you do, the better you get. People do hurdles, you know. The more you hurdle, the better you get at hurdling. Same thing with maths. Want maths get easy, want to win maths exam easy, want to win race easy at champs, you train hard. Want to pass exam easy, study hard. Same thing. All right. We have some tracksman in the class, you know, so they understand what I talk about. All right, so let's go. Next one again. More maths equals better maths every time. All right, I could shot this one now. keep doing that. All right, teacher, no, that's another exam paper. This is from January 2018. 2 years ago, this. January 2018. They give us two matrices, A and B. But you can see that A is -1, 0, 3, 2, and B is 3, 2, 1, 3, 2, 1, 1, 4, 4, 2. So this one is a 2 by 2. This one is a 2 by 2, 2 by 2. This one is a 3 by 2. It have 3 rows and 2 columns, 3 by 2. All right, so this one is a 2 by 2. 2, write it out, you know, write it out. This one is a 2 by 2, and this one is a 3 by 2. The most ask us about the committee, the thing there now. Possible multiplication or not, you know. First one, I want us to find the inverse of A, the inverse of this one. Easy, soft. 1 over the determinant times adjoint. Let's do it quick. A to the -1 equal. I'm just working. I have to write over back no question on. Just answer the question. A to the -1 equals 1 over the determinant. What the determinant? This product minus this product. Simple. 2 times -1 is -2. The 3 times 0 is 0. Multiply by the adjoint. What's the adjoint? Interchange the elements on the first diagonal. Interchange them. 2, -1. Leave these two where they are. Change the sign. Leave them where they are. Change the sign. 0 and a sign set stays 0. The 3 becomes -3. This under here is -2. So it becomes 1 over -2 times 2, 0, -3, -1. So basically now I am dividing each value by -2. Therefore, A to the -1 equals, I'm going to put it now. I get -1, 0, 3 over 2, I can put 1.5 because the negatives cancel. The negatives cancel. So I can put 1.5 or I can put 3 over 2. And then this negative cancel again. I get 0.5 or I get a half. See there, half. So I can put half or I can put 0.5. If you want, you could have put this. -1, 0, 1.5, 0.5. Could have put that. But then I put this, I put that, get them off same way. I would leave this as my answer. I will leave that. I like to see my fractions. Good. Next part. See here, I'm telling you, so they must show this. See it? Show that A to the -1 times A equals I. So you have to know that I is the 1, 0, 0 on matrix. I told you that I like to ask that question. Remember I told you earlier today? See it there for yourself now. So you see Mr. Shaw not in a line. I know this thing like the back of my hand. I know everything with them set all the time. So I tell you that I ask this all the time. And I told that you also have to know what the I is. So I'm sure say them equal that now, the identity matrix. So you have to multiply the two matrices now and show say the I works out to be 1, 0, 0, 1. That's where you're supposed to get to multiply them. So let's do it now. The A and the A to the -1 and the A to the -1 in front. So this becomes the A to the -1 is this. All right, we can actually work it with a half, you know. We can work it with a half, no problem. So let's work it with the -1, 0, 3 over 2 and half. That is the A to the -1 times the A. And the A, where's the A again? The A is this guy up here. So -1, 0, -1, 0, 3, 2, 3, 2. And you multiply them and show the examiner, so you multiply them. Rows of the first matrix times the columns of the second matrix. We have space. We can multiply it below it. All right? We have space. So I'm going to multiply it on here. Equals, put on big equal there. So now. Remember now, first 4 elements to get in. The first one is the first row, first column. First row, first column. All right? And that is supposed to become equal to 1. So let's show you now. Hold on, there's something wrong. Oh, it becomes 1. It becomes 1. Because you get -1 times -1, which is +1, and 0 times 3 is 0. All right? So let's show the working out. So you basically get 1 plus 0 for that one. And then this element here now is first row, second column. First row, second column. That going to work out to be 0. Have to be 0. Have to be 0, guys. Have to be 0. All right. So we'll get it now. The Minus 1 times 0 is 0, and then 0 times 2 is 0. So you see it, you get in 0, you get 0 plus 0. And then this element here, so now is second row, first column. Second row, first column. All right? So it's this times that. That times that. Let's work it out now. Let's work it out. So it's going to be the 3 over 2 times the negative 1 and the half times the 3. 3 over 2 times negative 1 is negative 3 over 2, and the half times the 3 is positive 3 over 2, and that becomes 0. And then the element here now is second row, second column. Second row, second column. That's supposed to be equal to 1 when we finish. Watch it now. It's supposed to be equal to 1. See here? This times this is 0. Half times 2 is 1. So it becomes 0 plus 1. 0 plus 1. So that equals, this will equal to 1. This will equal to 0. This will equal to 0. And this will equal to 1. And that is the I matrix. Shown quite easily brushed aside. Quite easily brushed aside. We brushed it aside easily. See it? And we know. So you see, you have to know that the I matrix is this. You have to know it. All right. So I told you and I showed you. All right. So that's what else I want in this question now. Let's see what else I want. Determine A squared. Remember I gave you an A squared question yesterday? See it there? Determine the matrix A squared. What did I say? Showed it yesterday, you know, because I know it come on exam paper. What did you say A squared equal? Don't square the values. You have to carry out the procedure and multiply the A times the A. Put them side by side and work them out, don't it? Remember I told you yesterday?
Yes,
I showed you. Good.
Yes, sir. Yes, sir.
I teach you everything when I come for exam paper. You know? You don't have to worry about that. So put them side by side and multiply them, right? So it's minus 1, 0, 3, 2. Minus 1, 0, 3, 2 times minus 1, 0, 3, 2. Put them side by side and carry out the procedure. Don't square the values. If you square the values, you look like you don't have no sense. Don't square the values. And look like Mr. Shah never teach you. If you square the values, when you do the maths, it must look like Mr. Shah teach you. When people who Mr. Shah teach, I will shut up exam. All right, remember that. 4 values. First value again. First row, first column. Don't give it away. Minus 1 times minus 1, 0 times 3. Minus 1 times minus 1, 0 times 3. That's minus 1 plus 0. Then this value here. First row, second column. First row, second column. First element by first element. Second element by second element. Let's go again. Do the maths like Mr. Shah teacher. Can't go wrong. If you do it like I'm a teacher. Can't go wrong. Ready now. Minus 1 times 0 is 0. 0 times 2 is still 0. Then this element now right here. Second row, first column. Second row, first column. Multiply them. First element by first element. Second element by second element. Second element by second element. First element by first element. Second element by second element. So it's 3 times minus 1 and 2 times 3. 3 times minus 1 is minus 3. 2 times 3 is 6. And the last value here now, the last value down here now is second row, second column. Second row, second column. First element by first element. Second element by second element. 3 times 0 and 2 times 2. 3 times 0 and 2 times 2. 3 times 0 and 2 times 2. 3 times 0, 2 times 2. 3 times 0 is 0, 2 times 2 is 4. Work it out now. Final value, minus 1, 0. 6 minus 3 is 3. 3. 0 plus 4 is 4. 4. What ups? Answer. Done. Soft. How we stay? But good?
Yes, sir.
Good. Another example for this now. What is now? What is now? Explain why the matrix product AB is not possible. Explain why the matrix product AB is not possible. Similar question what them just asked a while ago. Let's look back at AB. See A up here, so and B up here. So see them here? A and B. Not possible. Why is it not possible? AB. Why is it not possible? AB. AB.
Because the columns in B are more than the rows in A. Sir.
Don't say more, man. Don't say more or less. It does not equal. Don't have to build more or less. Just say the number of columns in the first one not equal to the number of rows in the second one. For them to be for the multiplication to be possible, the number of columns in the first one, which is A, this thing not right, stop right. The number of columns in A must equal the number of rows in B. Number of columns in the first one must equal the number of rows in the second one for the multiplication to be possible. So AB is a 2 by 2. I'm going to do this on the exam paper too, you know. I'm going to put this on the exam paper. That's a 2 by 2. 2 by 2 times a 3 by 2. I'm putting that on the exam paper and the examiner see, you know. And I'm marking it, make the exam system know me I talk about. Them two here, again, not equal. And then I tell him in words. Right there, so. Number of columns in A not equal number of rows in B. That is the reason, 1 mark for that. That is the reason. I'm going to show it right here, so I'm going to show it to him see it. They're not equal. Number of columns in A not equal number of rows in B. Next part now, without calculating the matrix, state the order of the product BA. State the order of the product BA. So watch this now. B times A. Watch this now. I give my thing now. B times A. B times A. B times A. B times A is going to be a 3 by 2 times a 2 by 2. See it here now? I tell the examiner now, I show some know my stuff. Them two are equal now. Equal. Them two are equal. Therefore, possible. Because them equal, the multiplication is possible. And the result, I'm going to show him what the result is. The result is going to be a this by this. Let me circle and make him see. It's going to be a 3. Circle them in blue. Make Uno see. It's going to be a 3 by 2. A 3 by 2. This is my answer right there. It's going to be a 3 by 2 matrix. That's what the question asks, you know. B times A is a 3 by 2. That's 3 by 2 matrix. 3 rows, 2 columns. See, that's the order of the matrix. 3 rows by 2. In fact, may I spell it out? 3 rows by 2 columns. That's then everything. 3 rows by 2 columns is a 3 rows by 2 columns. 2 columns matrix. 3 rows by 2 columns. Tell him everything. So him can't say, you know, tell him. If you put 3 by 2, I forget your marks still, you know, but that spell it out so everybody understand. Everybody understand that question? Yes?
Sir, I have a question. Can you scroll up back to number 3?
Number 3, right here.
Yeah.
Mhm.
For the one you have -1 plus 0, wouldn't it be +1 plus 0 because you have -1
Very
times
good.
-1?
Thank you very much. Yes, -1 times -1 is +1. Thank you very much, darling. You're a darling right there. Thank you very much. Wonderful. Somebody's paying attention. Good. Lovely. The -1 times the -1. What you saying that the -1 times the -1 give me this +1, and then the 0 times 3 is 0. Thank you very much. Lovely, beautiful, sweet. All right. That's it. Good. So that's a calculation error. We know what we're doing, but sometimes make those little mistakes. You don't make them do it now. Leave them to me. We don't do exam a long time. You don't make them. So say, course, she see it, and sharp, say more sharp too. All right. Everybody good?
Yes.
But all right? All right. Beautiful.
Yes, sir.
All right. More maths equals better maths. We'll go again. More maths equals better maths. Let's go again. All right. Let's see. Let's see. The next one is, we'll shot to 2 more and we'll call it a day. All right. 2016. Let's see. Let's find another one. This one right here. Let's go. Page 32. Page 32. Alright, this one, you know. Bam. Run through this fast. This question says matrix M is defined as this. Matrix M is defined as this thing right here. That's a matrix M. It said determine the value of P for which M is singular. Bam, 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 bam. So remember now, if M is singular, what do we know? Has no inverse. If it is singular, it means that it has no inverse, That is one thing that we know. If it is singular, has no inverse, 1, has no inverse. And the second thing is that the determinant equals 0. And this is what we use for the purpose of calculations, right? So because it's singular has no inverse, we know that the determinant of M is equal to 0. It means that this product minus this product is equal to 0. So let's look at it. It means that 2p times 1 is 2p minus 3 times negative 4, 4 times negative 3. 4 times negative 3 is negative 12. You have to be careful now, you know. And that equals 0. Understand that? This
Yes, sir.
2p is that is that, minus, and then the other product now is negative 12. So we are subtracting negative 12. So it becomes 2p plus 20, 2p plus 12, sorry. It becomes 2p plus 12 equals 0. If you over the 12, we get negative 12 divided by the 2. We see that the p equals negative 6. P equals negative 6. That is the answer. This is the answer right here. P equals negative 6. But I get that? But good?
Yes, sir.
All right, good. Next part now. We're calculating A and B are two by two matrices. This is A and that is B. And I want us to calculate this. Easy. 2 times this plus this. Let's work it out quickly. Let's just put it here. So equals. 2 times A means that we double the figures. So it becomes 2, 4 minus 8, 6. That is a 2A. A plus B. And the B becomes 5 minus 1, 0, 3. And they just add the corresponding values now. So it becomes 2 and 5 is 7. 4 minus 1 is 3. Minus 8 and 0 is still minus 8. 6 and 3 is 9. 6 and 3 is 9. 9 minus 8. That is the answer right there. Easy. But good? Next part wants B to the minus 1 right here. So we're doing the inverse of this matrix up here. All right. So B to the minus 1. B to the minus 1, remember, is 1 over the determinant of B times the adjoint of B, which is, let's put it here so now, which is, okay, I'll put it under it. Let's put it under here, which is 1 over the determinant is, we're doing B now. Remember, it's B we're doing now, this one. 1 over the determinant is this product minus this product. All right, so it's 5 is 15 minus 0. Multiply by the adjoint. Interchange these two on the leading diagonal. 3 up here, 5 down here. Leave these two where they are. Change the sign. 1, 0. So this is now 15. This works out to 15. So it's 3 over 15 or 1 over 5. 1 over 15. 1 over 15. 0 over 15 is still 0. 0. 5 over 15 is 1/3. 1/3. So we can leave that as the answer. So this is the answer. Yeah?
Sir, for CY, you never multiply by 2 as well.
Huh?
Oh, no. Oh, no, sir. I just.
It's 2 times the A alone. All right, cool. 2 times the A alone plus the B. All right, so this good? Better go down here?
Yes, sir.
Yes, sir.
All right, beautiful. Let's move on. Next thing, let's know. Given that this equals that, find the value of A and B. Now, what we have to realize now is that this matrix right here is really the B matrix that we just worked with. See here? It's the B matrix, you know. See that? So you have to realize that that's the B matrix that we just did. And it just asks us for the inverse of B, which also, if we want, the B to the minus 1, the B to the minus 1 is also 1 over 15 times 3105. 3105. All right, that is also the B to the minus 1 if we want to use it down here. But if we realize that this is really B, so what that means, because that is B, let's write it out. What that means is this is really B times XY equals 93. Therefore, XY is B to the minus 1 times 93. Good. So we just need to put the B to the minus 1 here. So now, so this is the B to the minus 1 we're going to put there. All right, and work it out. So it equals, leave the fraction for last, 1 over 15 times 3105. That is the B to the minus 1 times the 93. This is the B to the minus 1 right here. All right, and then now we're just working this down. Working this down now. Let's work this down now. Leave the fraction for last. So it's 1 over 15 times, remember the rows of the first matrix times the column times the 1 column. Rows of the first matrix times the 1 column. All right, so it's going to be 3 times 9 is 27, and 1 times 3 is 3. And then 0 times 9 is 0, and 5 times 3 is 15. So this becomes 1 over 5, no, 1 over 15, 1 over 15, not 1 over 5, 1 over 15, bracket 30, 15. It's supposed to be 15, not 15. Mark, I'm messing up sometimes, you know, 15. So that 15. See that? So you get values that can be easily divided by 15. That's what normally happens. So it basically becomes 2, 1. And once you get 2, 1, this is xy equals 2, 1, you know. You can therefore say, therefore, x equals 2, y equals 1. And that is your answer right there. Done. More maths equals better maths. But good so far? It's a good
Yes,
amount.
sir.
Let's do one more for the rule. What time is it? One more for the A. I will do one more for the distinction. Come. One more for the distinction. We're working on the distinction from now. And I ramp for this distinction. You know. I could do one more. All right. So we'll do which one? The last year now. Last year paper. This. Last year paper. That's what them said last year. Soft. No matter which year. All of them soft same. Once you practice, they'll all be soft. More maths equals better maths every time. All right, so we'll shut that one here now. See here? So from 2019, last year. Right? last year paper this we're gonna do now. Let's see what they say on this one. So this one gives us that matrix. I'm gonna say find the product. The only thing, if you notice, is that they want us to find the product, you know. They want us to multiply them, you know. Right? They want us to multiply them, but they have letters in them. So if we just leave the answers with the letters in it. So find the product, you know, multiply them, but don't make the letters throw you off. Just leave the answers with the letters in it. So I'm gonna write equal and put the column here to go equal. Now remember, is the rows of the first matrix times the one column. All right, so 2 elements you're going to get because a 2 by 2 times a column matrix gives you back a column matrix. Element here is the first row and the one column. First row with the one column. So it's minus 1 times k and the 3 times the 5. So let's write that. Let's write that, guys. Let's write that. Minus 1 times k is minus k and the 3 times 5 is 15. Done. And then the other value down here now is second row with the one column. Second row with the one column. So it's a 4 times the k and the h times the 5. 4 times the k and the h times the 5. 4 times k is 4k. 4k and 5h. Right, that's smaller. 4k plus 5h. That's it. That's the answer now. We can write it like this. Write it like this. We can say equals 15 minus k and 4k plus 5h. That becomes the answer now. You have to leave the h, you have to leave the letters in the answer. All right, next part now. Next part says, hence, find the value of h and k which satisfy this equation. So basically what this is saying now is that this part which we worked out to be this, that's what we just worked out now. This is the same as this. We just worked out. So and they're telling us now that it is equal to 0, 0. What does that mean? It means that this implies that the 50 minus k and the 4k plus 5h is equal to the 0, 0, because this side work out to be that. We worked that out already. Right? Write the k better. Don't like how this k look. You understand? So it said this equals 0 and this equals 0. This is a plus. This is a plus. This mark I'm messing up now, man. This is a plus. Plus 5h. So we can say therefore 15 minus k, marker gone bad, equals 0. It therefore means that the k equals 15 and 4k plus 5h equals 0. And we know so the k are 15 from yesterday now, you know. So 4 times 15 plus 5h equals 0. Divide through by 5. You get 4 times 3 plus h equals 0. Therefore, h equals negative 12. This is going to be 12. Q over the 12, you can get negative 12. That's it. If you want, you could work this out as 60. Q over the 60 and divide by 5. Anyway, take it. 6 divided by 5 is 12. This is negative 12. So that's it. K equals that and h equals negative 12. But good? But okay with that?
Yes, sir.
All right, so those are the answers right there. Next part. Use a matrices method to solve that. And we want to write it as matrices first, right? Same thing again. Always do the check. X followed by y in the first one, yes. X followed by y in the second one, yes. What you do now, you write a matrices equation. So that implies your matrices equation will come at 2 by 2 times xy equals the 5 and the 13. And you're putting the coefficients in here. What are the coefficients? 2, 3, minus 5. There's no number in front. The y is a 1. 1. That's a matrices equation. What it means now? We're trying to solve it, Trying to solve it means we're trying to find x and y. It means that the xy equals the inverse of this goes in front. All right, so let's do it. The xy is therefore equal to the 2, 3, minus 5, 1 to the negative 1, meaning to the inverse, times the 5, 13. But this is 513 now. 513. Good. So remember now, this is to the negative 1, guys. This is to the negative 1. This is negative 1. Meaning I have to do the inverse of this matrix. I'll put it right there. All right. So I'm going to work it out now. All right. Let's work it out. So the xy, so you can say therefore the xy equals, I'm doing the inverse of this matrix here now. It becomes 1 over the determinant. What's the determinant? This product minus this product. All right, so make sure this is 2, 3 minus 5, 1. Yes. So this product is 2 times 1 is 2 minus this product is negative 15. So I'm subtracting negative 15. 2 minus negative 15. Multiply by the adjoint. How do the adjoint now? Interchange the elements on the first diagonal. 1, 2. Leave these two where they are, change the sign. Negative 3, 5. This is just my inverse matrix, and I'm multiplying it now by my 5, 13. But I understand that. That's my inverse matrix. Now this under here is actually 17. Leave the fraction for last. So I get 1 over 17. And then I do this calculation. Work out them two there right now. Remember, how you work them out? Rows of the first matrix times the 1 column. Rows of the first matrix times the 1 column. I am going to get a 1 matrix. 1 matrix with 2 values. How we get them? First value here is this row times this column. Right? So it's 1 times 5 and minus 3 times 13. 1 times 5 and minus 3 times 13. 1 times 5 is 5. Minus 3 times 13 is minus 39. Minus 39. And then the value down here is this row and this column. So it's 5 times 5 and 2 times 13. 5 times 5 and 2 times 13. 5 times 5 is 25. And 2 times 13 is 26. 26. And wrote them out now. Bam. This equals 1 over 17 bracket. This works out to negative 34. Negative 34. And this works out to much? That works out to 51. 51. So you see that these are perfect multiples of the 17. So you can divide each of them by 17. So it becomes negative 2, 3. Negative 2, 3 again. Negative 2, 3. So the xy equals negative 2, 3. So we can write the answer now. Therefore, the x equals negative 2 and the y equals 3. And that's it. Like I can test these answers in the question of the top. X equals negative 2 and 3. X equals negative 2, y equals 3. Test it in this one. 2 times negative 2 plus 3 times 3. What that give you? Negative 4 plus 9. Negative 4 plus 9 is 5. Bam, see there, 5. Test it in this one now. Negative 5 times negative 2 plus the y value is 3. This works out to a positive 10 plus 3. 10 and 3 is what? 13. Bam, that's 13. So so the answer is correct when you test them. So sometimes you can test the answers and see if they're correct. Test the answers in the equation. Test these answers in the equation and see if they work out, which they do in this case. So you know the answer is correct. All right, anything else? If there's anything else, nope, that's it. Matrices part done. Okay, guys, I think we had a good run today. So only thing that is left for you to do is your homework. Your homework. Let me show you. It's in your handout. It's in your handout. All right, it's in your handout. Where is it? Homework. It's in your handout, guys. Yep. I want you to do all these questions because more maths equals better maths. See them there? I want to do all those questions for me, please and thank you. All right. All those questions for me. All right. It's in your handout. See there, matrices homework. That's 1 page of questions. Remember to study the must know items. Remember to study these must know items. No, not that. Study these must know items, please and thank you. Study these matrices must know items, everybody. Very important. Study them. They're all in your handout. You study all of these things, then you won't have a problem with matrices. All right, these are the things that you need to know. You also have these questions in your handout, you know, these. You also have these questions, but a lot of these questions are the same ones that I'm showing you on the other page a while ago. Some of them are the same, but I think these are also in your handout. So write these questions, someone, please. Finish all of them by Wednesday. On Wednesday, you're going to get a nice, easy classwork. So on Wednesday, I start the class working out some of these questions. Just work out some of these questions. All right? I'll work out some of these questions. Maybe do a couple more past paper questions. All right? And then we'll take it from there. Sunday, we're going on to the nice transformation topic. You cannot do transformation unless you know your matrices inside out. Left and right, up and down. You have to be able to do matrices in your sleep if you're going to do the transformation. If you know your matrices, the transformation becomes that much easier. Okay? So that is that for today. That is it for today, guys. That is it for today. Today was a fun class. I liked it. I like when people see the mistake that I'm making and correct me. Shows me that you're paying attention. I'm very, very impressed by those things. I like to see those things. Show me that people paying attention. Why not coming up now? Came up early and why not coming up now? Understand why? But anyway, it's in your handout still, you know. You just need to go and do the questions, right? It's all in your handout, those questions.
Sir.
All right. Very good?
No. Sir.
Yep.
Can someone copy of the handout?
Just send me a WhatsApp request.
All right.
Send a WhatsApp to me. Let me see, because everybody's supposed to have it by now. But send me a WhatsApp request.
All right.
I'll send it to you. All right?
Yeah.
Yeah, man. Cool. Coolie. Everybody good? Everybody have any questions? Everybody all right? Everybody good? I'll do another question. Everybody good? Get enough? Everybody get enough?
Yes, sir.
Sure. All right,
Yes,
then.
sir.
So we call it a day then. I will pick it up back. Pick it up back on Thursday, right? On Wednesday. All right. Okay.
Yes.
Yes, sir.
Yes, sir.
All right. Shut it up and we'll talk. All right. Bye.
All right.
See you all on Wednesday. Okay.
Yes.
Bye.
Yes, sir.
All right. So I'm gonna end it for everybody now. Okay. Bye.